Okay, so we can also find the area of a triangle when we don't know the height by using Heron's formula. So this A, B, and C are really the side lengths. Usually we call the side lengths or label them with lowercase a, b, and c. So I'm just going to put lowercase a plus b plus c, and we divide that by 2. So technically a plus b plus c would be the perimeter. So it's called a semi-perimeter because it's only half of it. So when we take that number, we'll call it S, right? The perimeter divided by 2, we'll call it S. And we plug it into this formula. The square root of that semi-perimeter times S minus A times S minus B times S minus C, that gives us the area as well. And it doesn't matter if I have a triangle that's a right triangle or not a right triangle, I can use this all the time. So technically, if I have a triangle with side lengths 12, 15, and 9, this is a right triangle. I could use the regular formula because I have everything I need. But let's check the formula here. So formula says that I need S, so I'm going to add up 12 plus 15 plus 9, all the sides for the perimeter, and then divide that by 2. All right, so when I add 12 and 15 and 9, let's see, we get 36. Divide that by 2, I get 18. So for my area, I need that number quite a bit. So I'm going to say it's 18 times 18 minus 12 times 18 minus 15 times 18 minus 9. So that is my area, but of course I'm going to go ahead and simplify. 18 minus 12 is 6, 18 minus 15 is 3, 18 minus 9 is 9, and then I'll multiply all those together. So I have 18 times 6 times 18 again times 9 is 17,496. And when I take the square root of that number, oops, a little typo. All right, let's try again. So 18, because this should be a perfect square since I have 18 and 18 and 9. So 18 times 3 times 6 times 9. There we go. I'm going to erase this. Put the wrong number in. So it's 2,960. When I take the square root of that number, then I get 54. That makes more sense. So 54 would be my area. Now if I were to look at this, I don't have to use this formula if I have enough information for area equals 1/2 base times height. So if I were to have this triangle and know that it was a right triangle, right, I have 15 here, I have 12 and 9. I could have just said, oh, this is a right triangle. I have the base, I have the height. Our normal formula, area is 1/2 the base times the height, which is 1/2 of 108, which is half of 108 is 54. So the area formula that we're used to gives me the same answer as this new formula. Only difference is this formula is more versatile. I can use this even if I don't know the height. I didn't even have to know which one of these was the height. This formula still works. Okay. All right, let's look at one application problem where we're having to find the area. So it says a parking lot has the shape of a parallelogram, and we know for a parallelogram that the opposite sides are parallel. Opposite sides are parallel, which also means that there's a lot of congruency. The angles opposite of each other are the same. Same side interior angles are going to add up to 180. We don't necessarily need that. We know that the sides are opposite are also the same. So this is 70 meters and this is 100 meters. Okay, it says the lengths of two adjacent sides are 70 and 100. That's what we were given. We can copy those as well. It says find the area of the parking lot if the angle between is 70. Okay, so right now we don't even have a triangle, and all we have is the formula for a triangle. So I'm going to split this up so that it looks like a triangle. Okay, so if I have, put a paper underneath here. If I have two side lengths and I have that angle in between, all right, just kind of cutting it in half into two equal triangles. Okay, so whatever I get for the area of this bottom triangle is also the same area for this top triangle. So I'm just going to find the area of one of them and then double it. But for the area formula that we have, since this is not a right triangle, it's not 90 degrees here, I don't know the height, all I know is 70 and 100, I have to find this side length here. That way I can use Heron's formula, plug everything in. Right, so I have that, my triangle here, I'm just going to redraw it. Go here, so I have 70 degrees, I have this is 100, this is 70 meters. I don't know this side, right? But it's across from the 70, which we don't know if that's the largest angle yet, but it's across from the 70. So I'm just going to start labeling. Let's call this A and A. We'll call this B and B. And then we'll call this angle C. This guy C. Okay. I do know that the largest angle, though, is across from the largest side. So when I find side A, I would know what the angles are. But actually, we're looking for the side length so that we can use Heron's formula. So let's just find side A. So I'm going to use the law of cosines, find that A squared is B squared plus C squared minus 2BC cosine of A. Right? We know angle A, we know side B and C. Let's plug everything in. So I have 100 squared plus 70 squared minus 2 times 100 times 70 times cosine of 70 degrees. All of this can be plugged into my calculator, and that's my A squared, and then I'll find what just A is. All right, so we have 100 squared plus 70 squared minus 2 times 100 times 70 times cosine of 70 degrees, which gives me 10,111.72. If I square root that answer, that will give me about 100. So 100.56, we'll say, and everything's in meters. So now I know that the diagonal is 100.56, which means in Heron's formula, I have everything I need. Put here 0.56. I have everything I need. I have an A, B, and a C. I'm going to plug them all in. Okay. So Heron's formula says that if I know the perimeter, right, which is add up all the sides, so 70 plus 100 plus 100.56, and I divide that by 2, that'll give me the semi-perimeter. So let me add all those and divide by 2. Get that, and we divide by 2. We get 135.28. And then I'll say, well, now I know my area is the square root of 135.28 times 135.28 minus 100, 135.28 minus 100.56, and 135.28 minus 70. So just taking that number and subtracting it from all of my side lengths. So let's see if we can break some of these numbers down. 135.28, and then 135.28 minus 100 is just 35.28. If I subtract these, get something a little less than 35. Let's see, 135.28 minus 100.56, 34.72, and then 135.28 minus 70, I get 65.28. Now I'm going to multiply all these numbers and then take the square root. So I have 135.28 times 35.28 times 34.72 times 65.28. All right, which is a large number, but I need the square root of that number, that answer. So then I get the area is 3,288.98, we'll say. And everything was in meters, so this is meters squared. All right, so when I go back to my equation, I was looking at a triangle that had lengths 70, 100, 100.56. I found that the area of this guy was 3,288.98. That means that this is also the same area. So when I find the area of the parallelogram, I'll just put here area of the parallelogram, it's just going to be twice the area that I just found. I have two triangles in there. Just multiply that number by 2. And we get 6,577.96 meters squared. Okay, so I think you have one or two problems that ask you to find the area of a triangle or some shape using Heron's formula. So just go ahead and try a couple and then let me know if you have any questions.